All right, so the last section for this week is going to be section 3, which deals with decimals and fractions. So the first thing I want to go over here is just that I want to teach you how to convert a fraction. Oh man, my handwriting is terrible there. Let's try this again. Let's try this all over again. All right. We're going to convert a fraction to a decimal. All right, and I can sum this up in one word. All you got to do is divide. That's it. So let's go ahead, let's see this. 3/4, and we want to convert this into a decimal. Now, remember, the numerator is your dividend. The denominator is your divisor. So, here's our setup. Now, when we ask the question, can 4 go into 3? The answer is no, 4 is too large. So what do? We introduce a decimal, we copy it directly above, and we add a 0. And that is the key on how to convert a fraction to a decimal. So 4 goes into 30, 7 times, it's going to be 28. Subtract, you get a 2. Now we know we can keep adding zeros if we wanted to. 4 goes into 20 5 times. And now we get that remainder of 0, so we know we're done. So 3/4 is equal to 0.75. Now, there are some times we got to be a little bit careful, like in this example. Let's convert -9/5 to a decimal, all right? Well, here you got a negative fraction, which means your decimal is also going to be negative. So I'm not going to worry about the negative sign yet. All I'm going to do is set up my problem. All right. Oh, sorry, I got these backwards. I do that from time to time. My bad. And now we're just going to go ahead and divide like we normally would. 5 goes into 9 once. With a remainder 4, but we know we could take this one step further now. We're not going to write remainder 4. What we're going to do is we're going to introduce a decimal, write it directly above, and put a 0, and then drop it down. 5 goes into 40 8 times. 8 times 5 is 40. So you get a remainder of 0, which is great. So, and you got to remember, -9/5 is equal to -1.8. Okay, remember, your original fraction was negative. However, we may run into this situation here, okay? If we run into this situation, like 1/3, and we want to convert it into a decimal, we still set up the same exact process. 3 does not go into 1. So what we do is we put a decimal point, put it directly above, and add a 0. Now, here's what's going to happen here. 3 goes into 10 3 times. It gives me 9, and I subtract. I get a 1. Now I add a 0, drop it down. 3 goes into 10 3 times. I get a 9, subtract, that gives me a 1. I add another 0, and I just keep doing this. And what we find is it looks like I'm never, ever, ever going to get that nice remainder of 0. I always get 1, and then I drop down to 0. And in the numerator, or in my quotient here, you could see that I start getting this 3 that just keeps repeating. So what we say is 1/3 is equal to 0.3, and then we put a bar above the 0.3, and that bar stands for the repeating part of our answer, okay? So we say 1/3 is equal to 0.3 repeating. And that just means that 3 just repeats endlessly. All right? Now, I want to be really specific with this. Okay? And that's because that bar only goes over the repeating part. That's it. So let's look at another example here. We're going to convert 27 over 11 into a decimal. So everything stays the same. Divisor outside, dividend inside. 11 goes into 27 twice. I can subtract. That gives me a 5. But now I need to introduce my decimal. Write it above. Put a 0. Drop it down. Now 11 goes in the 50 4 times. That gives me 44. I subtract. I get a 6. Add a 0. Drop it down. And I keep doing this in hopes that I get a 0 or I get something that repeats. So 11 goes into 60 5 times. So that's going to be 55. So now when I subtract, I get a 4. Add a 0, drop it down. 11 goes into 40. Sorry, obviously Mr. Float cannot subtract today. 60 minus 55 is 5. Now we drop down to 0. 11 goes into 50 4 times. So that's going to be 44. Subtract, I get a 6. Add a 0, drop it down. 11 goes into 65 times. So that's going to give me 55. I subtract, I get a 4. Add a 0, drop it down. I did it again. 60 minus 55 is 5. Add my 0 and drop it down. 11 goes into 50 4 times, and it looks like I'm alternating between 4 and 5. 4 and 5. So 27 over 11 is going to equal 2.45 repeating. And we put the repeating bar above the 4 and the 5. Okay, we put it on above the 4 and the 5, okay? Now, the last example I want to do here is going to be 43 over 22. We're going to convert that into a decimal. So for this one, I'm just going to speed up just a little bit. Excuse me. So let's set up our problem. 22 goes into 43 once. So we subtract. We're going to get 21. Now I introduce a decimal, write it directly above, add a 0, and drop it down. 22 goes into 210 9 times. So that's going to give me 198. Now 210 minus 198, if I just subtract, I get 12. Add a 0, drop it down. 22 goes into 120 5 times. So that gives me 110. 120 minus 110 is 10. Add a 0, drop it down. 22 goes into 100 4 times. So that's going to give me 88. Subtract. 100 minus 88 is 12. Add a 0, drop it down. That gives me 120. 22 goes into 120 5 times. That's going to give me 110. So now I get a 10 again. Add a 0, drop it down. 22 goes into 100 4 times. That gives me 88. Subtract, it gives me 12. And now I can start to see that I'm repeating, but the only numbers that are repeating are the 5 and the 4. So 43 over 22 is going to be equal to 1.954. And the repeating part only goes over the 5 and the 4. That's it. All right? So now that we understand how to convert between a fraction and a decimal, we can do a lot of things now. We can do something like this. Let's compare 3/8 and 0.4 using are less than or greater than signs. Okay? Well, we already did 3/8 above. We know 3/8 as a decimal is going to be 0.375. Now, if you're asking yourself, well, why do I need to know that? We're comparing it with another decimal. And decimals are really easy to compare. So if we convert the 3/8 into a decimal, now we can compare just by looking at the numbers. 3 is definitely less than 4. So this is going to be less than. Okay? So now you can compare numbers. You can also do something crazy like this. Arrange the following in order. From smallest to largest. So we have 13 over 20, 0.61, and 11 over 16. So, excuse me, the first thing you're going to have to do is you're going to have to convert 13 over 20 and 11 over 16. Now, I'm going to leave you to do that, but I'm going to tell you that 13 over 20 is 0.65 and 11 over 16 is 0.6875. Now, please practice doing this because it's really important. So now what we can do is we can go ahead and compare. They all have a 6, so that stays the same. Now we have a 5, a 1, and an 8. All those are different. So the 1 is going to be the smallest. The 5 is going to be the middle number. And then the 8 is going to be the largest. So to put them in order, we go 0.61, 0.65, and 0.6875. And technically, what we should be doing is putting them in order the way that it was given to us. So 0.61, 13 over 20, and then 11 over 16. Okay, so make sure that when you are doing your homework that you are doing this correctly, okay? The last thing that I need to go over is just something that we've seen a bunch of times already, which is simplify using the order of operations, okay? So I'll do a couple of these because we should already know our order of operations. And just to reiterate, we got parentheses, exponents, multiplication, and division, left to right in order, and then addition and subtraction, left to right in order, okay? So here's our first example. 7 times the quantity of 18.3 minus 21.7. All right? So remember, let me write up my order of operations off to the right. We need to do all the work inside the parentheses first. So we need to combine those. When you combine them, 18.3 minus 21.7 is negative 3.4. So now that the parentheses are done, I don't have to worry about exponents. But now I'm going to have to multiply. So I have a positive number times a negative number. So my answer is going to be negative. And 7 times 3.4 is 23.8. All right. So now let's go ahead. Let's try another one here. All right. We're going to get more difficult. Let's do 6 divided by 0.6 plus 0.2 times 4 minus 0.1 raised to the second power. All right? So you got to remember your order of operations. So notice, even though we have parentheses first, we only have one number contained inside the parentheses. So there's no operations that we can do inside parentheses. So that one's done. Now we do have exponents. So what we're going to have to do is simplify this one first. So I rewrite everything the exact way that it looks right now, except 0.1 times 0.1 is going to be 0.01. Now, if you're asking, well, how did I get 0.01? Just remember 0.1 to the second power means 0.1 times 0.1. 1 times 1 is 1. 1 decimal place for a total of 2. So I put my decimal to the right, and I move it 2 spots to the left. 0.01. So that's how I came up with 0.01. Okay? Next, we need to worry about multiplication or division from left to right in the order in which they appear. So we're going to do 6 divided by 0.6 first. Now I'm going to let you do that, but the answer is going to be 10. Plus, now we can multiply these two if we wanted to. So 0.2 times 4 is going to be 0.8 minus 0.01. So now, addition and subtraction from left to right. So we're going to add those two first. So you're going to get 10.8 minus 0.01. And 10.8 minus 0.01 is going to be 10.79. So notice here, the order of operations did not change at all. The only thing that changed are the numbers I gave you. So that's, oh no, we got one more thing to go over. I thought that was going to be it for this lesson, but we got one more thing to go over. And that's going to be finding circumference and area of circles. So a circle looks like that. And within the circle, we have a couple things that we're going to highlight here. The first is this dotted line here. That's called the diameter. And then if I were to just take the middle of the circle and just draw a solid line to one side, that little distance is called the radius. Now, what's amazing is if you were to take the circumference and divide it by the diameter. So if you're asking yourself, what's the circumference? Well, the circumference is the distance around the circle if you were to walk it. So if you were to take the circumference of any circle that exists and you were to divide it by its diameter, so you measured this horizontal distance, you took those two numbers, and depending upon how accurate your measurements are, it always equals this number pi. Now, pi is approximately, let me use my approximately equal sign, is approximately 3.14. Okay? So, excuse me. I'm going to repeat what I just said, all right? Because I really want this to sink in. No matter what circle you pick that exists on this planet, if you took a piece of string, you wrapped it around the circle, and then you used a ruler to measure that distance, and then you used the same ruler to measure the distance at the diameter, and you divided the two numbers, C divided by D, it's always going to equal 3.14. This number pi is so special that it got its own symbol, and that's amazing. Now, we do have some formulas here that we can use to find circumference. So there's two of them. Circumference is going to equal pi times the diameter, or if you're only given the radius, then circumference is going to equal 2 times pi times r, which is the radius. Now for us, we're going to use, we're going to use 3.14 to approximate pi. That's going to make our calculations a little bit easier, all right? So, for example, if I want you to find their circumference for the circle, all right? And this is all I give you. Well, we know that circumference is this And I like to put my little self walking along the outside of the circle. So if I walked around the outside of the circle, that's going to be my circumference. And the only thing I gave you was the radius here. So I'm going to use the formula 2 pi r. And all I'm going to do is make my substitutions appropriately. So I get 2 times 3.14 times 5. Now, I'm going to be really smart on how I do this because I notice that 2 times 5 is actually 10. Remember, order does not matter when you multiply, so you can multiply any numbers you want. But the reason why I did that is because now I notice I have a factor of 10, which has 1 0, which means I'm going to move the decimal place 1 place to the right. So my circumference is going to be 31.4 meters. Okay? Now, if I wanted to find the area of the circle above, and let me just draw the circle again. So there's my circle. Here's my radius. It's 5 meters. Area, remember, is going to be the inside dimension of the circle. So it's like if you were to paint this, that would be the area. So now you need another formula. So the formula for area is going to be pi times r squared. Okay? So in this situation, we actually have to do a little bit of math. So area is going to equal 3.14 times 5 to the second power. And if we were to simplify this, you got to be careful because you got to do exponents first. So 5 to the second power is going to be 25. And now I have to take 25 times 3.14. And when I take 25 times 3.14, I get 78.5 meters squared. Remember, the units for area are always going to be whatever that unit is to the second power. Now, that's going to be it for this lecture. So I hope this helped, and good luck this week. Next week, we're going to look at solving equations, averages, some probabilities, ratios and rates, and then simplifying square roots. It's not as bad as what it thinks. It's actually pretty easy. So good luck this week, and if you have any questions, email me. I'll talk to you soon. Bye.